Hey there. Today we'll be discussing quantum computing. Have you ever worked on a computer or a laptop? Well, then answer this question. You were probably stumped there. Computers were designed to compute and now they have many more functions. Computers work on binary numbers and consist of transistors, which represents 0 in the binary when off and 1 when on. One transistor is known as 1 bit. Now, quantum computers have qubits instead of bits. Those qubits exist as 0 and 1 at the same time. Therefore, it can respond to the input faster. Quantum computers are just quantum systems. Therefore, it prefers to be in its lowest energy state or ground state. Simply put, they are lazy. Therefore, they tend to discover the shortest solution to a problem. Also, to protect our bits or data. In a normal computer, we use numbers. What else did you really expect? If someone manages to guess the magic number, he or she will steal your data. Well, there are hackers for that. But do you want to know the easiest solution? Hint, it's quantum physics. Normal supercomputers would take a ridiculous amount of time to encrypt a file, that is, to steal your data. If the information is in the form of numbers, which is something like 6943212478654 and so on, you're not guessing the numbers, especially if it's in binary form like 01010001. So, what do? We use the Shor's algorithm. Let's say we have a number 1024. This is pretty easy to factorize and it's just 2 raised to power 10. But let's say you do not know what the factors are, but you do know how to guess, right? Take 7 as a guess, for example. A property of number says that 7 raised to power n equals 1024 times k plus 1, or particularly p raised to power n equals m times b plus 1 for any number p or m. Rearranging, we get 7 raised to power n minus 1 equals 1024 times k. Since a square minus b square equals a minus b times a plus b, 7 raised to power n by 2 minus 1 times 7 raised to power n by 2 plus 1 equals 1024 times k. Well, we have a breakthrough here. Drum roll, please. This breakthrough is that you have a factor of the number. One of those terms is going to divide 1024, and you can apply the division algorithm to get other factors. This is true for all n which have 2 as their factors. You've broken the encryption. However, a pretty obvious constraint this method has is that it is slow. Now what should we do? Here's where the magic comes into play. If you have a quantum computer, you'll instantly get the answer. Due to superposition, you're going to get many answers, but the right answer is going to repeat periodically. You can work out its frequency via the Fourier transform, and this frequency equals 1 over n. Also now, we have a superposition of numbers which repeat periodically with a frequency of 1 over n. Now, if we get n, we gotta say RIP to the encryption. To get n, all we have to do is that we have to convert the inputs of different values of n in the superposition into the quantum version of the Fourier transform. The Fourier transform converts the frequencies into sine waves. These waves will help us to get n, since the wrong frequencies will be opposite to each other, cancelling out. The right frequency is the one which will remain. All this is happening in faster than millisecond times. and happens over and over and over again, causing the computer to work faster than light. That's a metaphor, by the way. This will help improve the processes which require repetition and make your computer faster.